Okay, so let's take a look at the different types of reactions. Now we know, or hopefully we remember from grade 10, that reactions are based on the reactants that are present and also the products that they form. And this allows us to name our reactants based on both their potential products, but also what's reactant. And we have 5 types that we learned about last year: synthesis, decomposition, combustion, single displacement, and double displacement. For our synthesis reactions, this is where 2 or more reactants come together and form one product. Okay, so we recognize synthesis reaction by the presence of one product. Okay, so our generic can be A plus B forms AB, and I recognize it by having one product. So we have a variety of different compounds or types of synthesis reaction. And by looking at our reactants, it allows us to predict our product. So for example, a metal plus a nonmetal will give me an ionic compound. And so we have an example here of sodium plus oxygen will give me the ionic compound sodium oxide. 2 nonmetals can also come together to form a covalent compound. Nitrogen plus hydrogen forms ammonia. Another synthesis reaction that we'll have to recognize is a metal chloride plus oxygen, which would give us a metal chlorate. So for example, our metal chloride, magnesium chloride, can combine with oxygen gas, and it would give us magnesium chlorate. Non-metal plus oxygen will give us a non-metal oxide. So for example, sulfur plus oxygen will give me sulfur dioxide. A metal oxide plus water can give me a metal hydroxide or a base. So for example, magnesium oxide plus water will give me magnesium hydroxide. And a metal oxide plus carbon dioxide can give me a metal carbonate. For example, magnesium oxide plus CO2 will give me magnesium carbonate. And a non-metal oxide plus water will give me an acid. So sulfur trioxide plus water will give me sulfuric acid. The opposite of our synthesis reactions are our decomposition reactions. And these are generally just the reverse of our synthesis reactions. But it comes down to, I have one reactant now in this case and more than one product. So our generic would be AB forms A plus B. So we have all of the ones we had before, where an ionic compound could break down into its constituent elements. So my sodium oxide could break down into my sodium plus oxygen. Covalent compounds could break down into their constituent elements. So I have my ammonia gas that could break down into nitrogen gas and hydrogen gas. My metal chlorate could break down into a metal chloride plus oxygen. So in this case, I have an aluminum chlorate. It could break down into aluminum chloride plus oxygen. A metal oxide can break down into metal plus oxygen. This is, again, just like an ionic compound breaking down into its elements. A metal carbonate can break down into a metal oxide plus carbon dioxide. So my magnesium carbonate could break down into magnesium oxide plus carbon dioxide. My metal hydroxide could break down into metal oxide plus water. And my acids could break down into a non-metal oxide plus water. So our examples are the reverse of the reactions we had before.